As part of the work of the Neocognition Laboratory, we'll share insights on the singularity of categories of thoughts in artificial intelligence. Specifically, we'll explore how synthetic cognition in artificial neural networks operates. The synthetic cognition of artificial neural networks is fundamentally categorical. It means that it analyzes and classifies data into specific concepts or patterns upon which these networks must act. Through these synthetic thought categories, the networks construct an image that is not a copy of a predefined external reality, but an expression of the dimensions of interaction. This interaction creates new synthetic meanings between the neural network and the world of data it accesses. But how do these artificial thought categories function, and what are they composed of? Are they analogous to our human thought categories? And how can we understand their specificities without centering solely on our own human cognitive frameworks? First of all, the activation level of an artificial neuron when presented with a word is the intensity with which this neuron reacts to that word. This activation level indicates how much the word is recognized or detected by the neuron, essentially, the extent to which the word belongs to the synthetic category specifically associated with that neuron. A group of words that strongly activate the same artificial neuron belongs significantly to the word category discriminated by that neuron. For example, picture a neuron that strongly activates for the words nothing, nobody, neither, never, and none. These words strongly belong to the nothing category represented by this neuron, enabling it to identify all words related to the concept of nothing. When examining words that strongly activate the same formal neuron, one might expect these words to be semantically close, as in the example above. More precisely, one could anticipate that words triggering similar high activation levels are semantically related. If a neuron classifies these words at a high and similar degree of belonging to its targeted category, this should imply semantic proximity. We studied the 100 most detected words, or more precisely, tokens, by the 12,800 neurons in the first two perceptron layers of OpenAI's GPT-2 XL language model. This represents 1,280,000 word occurrences. We highlighted a counterintuitive phenomenon of synthetic categorical cognition, the peri-activational categorical divergence of core tokens. This means that words activating the same artificial neuron with similar high intensities, indicating a strong belonging to the synthetic category associated with that neuron, do not necessarily appear semantically close. Consider these pairs of words, Fisher and cookies, unless and HTTPS, Bob and socialist, Hispanic and jazz. From a human perspective, these combinations seem random, even contradictory. So why does this happen? How can we interpret this semantic divergence? The answer lies in the fact that, for humans, this phenomenon seems paradoxical because we tend to think anthropomorphically. We project our own human characteristics onto the world and expect non-human systems to function in ways aligned with our own conceptions. Thus, we instinctively assume that synthetic thought categories should be unified in the same manner as our human thought categories. This means unified concerning the same subcategorical dimensions that we habitually use in our individual or cultural thinking about objects and events. However, different cognitive and cultural systems produce distinct thought categories, forming paradigmatic visions of the world that are qualitatively unique. This is evident in cross-cultural differences in human thinking, as shown by anthropology and intercultural psychology, and between human and animal cognition, as highlighted by ethology. We can readily imagine similar differences in the cognition of artificial intelligence systems. As an example, humans in the modern Western context categorize light blue and dark blue within a unified blue category because we prioritize the dimension of hue. Thus, we group colors with the same hue into the blue category, disregarding differences in other dimensions such as luminosity. However, this categorization is not absolute or natural. For instance, the ancient Romans categorized colors primarily based on luminosity rather than hue. Consequently, they grouped dark green and dark blue together within the same category, but did not categorize light blue and dark blue together. This example illustrates that categorization is a singular cognitive construct, not a passive or obvious reading of the intrinsic properties of the world. Similarly, synthetic thought operates through subcategorical dimensions determined by a neuron's functioning and aggregation mechanisms. A neuron's synthetic category comprises various subcategorical dimensions, gradually constructed and aggregated during its initial learning phase. These dimensions are determined based on their effectiveness in contributing to the tasks required of the neural network. They are tied to the strongest connection weights the neuron has with neurons in the previous layer. More precisely, a category of a neuron in a layer is composed of a combination of subcategorical dimensions constructed and extracted from the categories of neurons in the preceding layer with which it is strongly connected. This explains the phenomenon of synthetic cognition we observe, which appears as categorical divergence when viewed from the epistemological framework of human categories. Words that exhibit strong and similar activation levels in a formal neuron, indicating strong and similar belonging to the synthetic category detected by the neuron, may seem semantically heterogeneous because they relate to different subcategorical dimensions aggregated and combined by the neuron. Each word preferentially activates a different subcategorical dimension, creating an impression of categorical heterogeneity for an external human observer. Thus, the phenomenon of categorical divergence does not stem from absolute polysemy, but rather from the observer's frame of reference, whether human or synthetic. For humans, categorical divergence arises because the words involved pertain to different subcategorical dimensions that are not typically complementary or associated in human thought. However, for the synthetic cognitive system, its learning history led it to group and converge these subcategorical dimensions into the same artificial category, a statistical construct. In a technical view, the category associated with a neuron in layer activates for semantically heterogeneous tokens because these tokens preferentially instantiate specific subdimensions of the vector space of subcategorical dimensions uniquely extracted by this neuron from the vector space of categorical dimensions in its input in its layer. To conclude, the synthetic cognition of artificial neural networks reveals dynamics of world segmentation that differ significantly from those of humans. The periactivational categorical divergence of core tokens highlights a lack of correlation between the high-level belonging of certain words to the same synthetic category and their semantic proximity. This divergence is true within a human observational framework, but false within the synthetic system's framework. Synthetic cognition in some aspects is radically different from ours. It is crucial to understand it without imposing our specific cognitive categories upon it. This understanding reveals a distinct segmentation and construction of objects and events, enabling synthetic systems to uniquely dissect and reconstruct the informational flow of tokens they process. Thank you for joining us on this exploration of synthetic thought in artificial intelligence. You can find the article mentioned in the video, as well as all the work from Neocognition Lab on neocognition.org. See you soon for a new video.